Hello again, higher algebra students, back here with the third lesson of Unit 11, which is adding and subtracting algebraic fractions. So again, we've focused on simplifying and multiplying and dividing in the first couple of lessons, and now we're moving on to adding and subtracting. So I noted this back when we were simplifying as well, but if we look at an example like this, you can see obviously there's addition and subtraction here within this problem, but we do have a common denominator throughout. And so again, when we add or subtract fractions, we do like to have common denominators anyways. And this idea of being able to simplify with this common denominator, and again, you could write it separately like this, or keep it combined if you see the simplifying that can take place by factoring out the 2 here. But when we have it separate, this is really 3 fractions added and subtracted together. And in this case, we've got 4b squared, a 5b, and a minus 3. Now, we didn't technically add or subtract anything here because it was really just about reducing out that 2. But again, what this highlights is the notion of having that common denominator for adding and subtracting, and we're going to continue to work on getting that even when we bring in more of these algebraic fractions. So here again, we just have an integer in the denominator. So this again, we can rewrite as 9a over 3 plus d over 3. And 9a over 3 can reduce to 3a. So this does clean up a little bit, even though the second half of this formula doesn't change at all, but the second half of the addition here. But the first half does, in that 9 divided by 3 is 3, so we can squash out that denominator on the left side and just leave it on the right side. But again, worked with a common denominator there and had addition in between. But those are really more about simplifying. And so now let's jump in a little bit to what this fraction addition and subtraction looks like. So again, here's a problem where we already have the common denominator set. This is something you would have done years ago in your math class. And when we have that common denominator, it just is along for the ride. And then we just add up or subtract the numerator values, which in this case is just 6 plus 2. So we get an answer of 8 over 11. And that would be our final answer there with the common denominator of 11. Now here, where we don't have the common denominator, if you recall here, what our goal is to obviously get these to be a common denominator. And the easiest way to do that is really to just multiply each fraction by the opposite denominator. So for instance, I'm going to take this first fraction and multiply by 5 because that number was 5. I'll take the second fraction and multiply by 3 because the opposite denominator was 3. So when I multiply by 5 here, I should note I'm actually multiplying by 5 over 5 and by 3 over 3. Because when we multiply by 5 over 5 or 3 over 3, that just means we're multiplying by 1. So we aren't changing the value because anything multiplied by 1 is still that anything that it started as. 100 times 1 is 100. 3/5 times 1 is 3/5, and so on. So what we have to do is not just multiply by 5, but we're really multiplying the numerator and the denominator by 5. So this would be 10 over 15 as our first fraction, plus 12 over 15 as our second fraction. So I've done essentially the opposite of reducing these. I've increased that denominator just to make sure that I can get to our common denominator here, which is 15. And now, as a final answer, again, I just keep the 15 in the denominator, and 10 plus 12 is 22. So similarly, on the second one here, I'm going to multiply the first one by 6 over 6, since that's a 6. And I'll multiply the second one by 7 over 7, since that's a 7. And what, again, I'm doing here is I'm ensuring that I get a common denominator. Now, there are times where there's a lower common multiple of these two denominators, but again, this will always end up working here, especially with these numerical values. And even when it gets more complicated, it just looks a little different as we build on this. But I can rewrite these then as 6 over 42, which is the same as 1/7, minus 35 over 42, which is the same as 5/6. And then 42 is along for the ride as the denominator, and 6 minus a 35 is a negative 29. 29 is a prime number, so we know that we can't simplify or reduce this any further. So this would be our final answer here. Again, this is just kind of a recap, of a reminder of how we add and subtract fractions with unlike denominators. Now, as we bring in polynomials, you can see I've kept the common denominator here, but what we're really doing is now adding a little more complicated term in the numerator. Now, last unit, we talked about just adding polynomials together, and again, when we have this common denominator here of 3, we can really just add these together all in one shot. So at that point, what we're really doing is just combining like terms. So we have a 4 plus a 6, so that gives us 10x. We have a -1 plus a 5, so that gives us 4. So again, I just combined the x terms, and then I combined the non-x terms. And again, the 3 was along for the ride. From there, we could simplify further if it's possible, if there's an x that we could simplify out, or a common factor of these two that we could simplify out. Here, we can't really do anything else with this, so we'll just leave it as 10x plus 4 all over 3. And again, thankful to our common denominator there that we just got to combine the like terms. Similarly, on the bottom here, we have this common denominator already. And so going back to last unit, again, when we had to subtract a polynomial, this is like having a -1 out in front. And so the -1 and the 2y means it's minus a 2y. -1 and a -10 makes it actually plus 10. So that's subtracting a negative as we carry it through that parentheses. So the minus a negative here, or minus a minus, made this a plus. And so again, we can just combine our like terms. The only y squared term was the one in the beginning. The only y term was the minus 2y, which was the subtracting the 2y here. And then we had a positive 7 and again a positive 10 here. So we ended up with a positive 17. And then we divide by 3 again, since that's our common denominator. Again, we could look for ways to factor something out here to simplify a little further, but there isn't anything here. So this would be our final answer for that problem. A couple more here. Now we've got this situation where we do not have the common denominator. And again, how we manage this 5 and 3 is let's get these to a common denominator again. So similar to what we did previously, I'm going to take my left side and multiply it by this 3 over 3 so that we can again focus on getting that common denominator. So when we do that, that makes our left side here a 12x minus 3 over 15. Again, similar to what we did, we're just building up, kind of unreducing this, if you will, tripling the top and tripling the bottom. And similarly on the right side, we're going to multiply by a 5 over 5, which is the denominator of the other, so that we can get this denominator to be 15. And when we do that, 5 times 6x is 30x, and 5 times 5 is 25. And you can see now the process is I can essentially just take this plus out of the middle and extend this fraction bar, make it just a single 15 on the bottom, and put the plus up here now instead, which again would be that plus right there. So when you combine the like terms here, you have a 12x plus a 30x, so we have 42x. We have a minus 3 and a plus 25. Minus 3 and plus 25 makes us a plus 22. And then we divide by 15. And again, we can look and see, can we simplify this at all? Well, the factors of 15 are 5, which doesn't work here. 3 doesn't work. It would for the first term, but does not work for the second term. So we could, if we wanted to, and I'm not going to do this here, so I'll just try and put it lightly, we could reduce this part and leave the second half as 22 over 15, but have the first part be 14x over 5. But again, we don't have to do that, just to reduce that one part here, since it's not adding a ton of value on the simplifying. So we'll leave this as our final answer here. And that's our first one where we can build that common denominator. Similarly, on the second one here, working with a little smaller numbers, which is kind of nice here, but we're going to take and multiply the left side here by 3 over 3. And when we do that, that leaves us, as we distribute here, on the left side with a 15y squared plus 21 all over 6, so 3 times 2 there to get the denominator. And then on the right side, we're going to multiply by a 2 over 2 so that we get that 6 in the denominator again. And as we distribute that 2, that gives us a 4y minus 20. Now again, we got to mess with the minus here. So what we're going to do with that, and I'll change colors here, is we're going to have the 15y squared. Sorry, I should probably put parentheses around both those just to remind you of that. 15y squared plus 21, and then again minus a 4y and minus a negative 20. So that would be plus 20. And that's all going to be over our common denominator of 6. And so we combine like terms again, and we've got a 15y squared. We still have the minus 4y. And then we have plus 21 and plus 20, so plus 41 all over 6. And again, there's not a lot we can do to simplify there that helps. You can see the middle term, 4 over 6 is 2/3, but again, and you could even divide by 3 on that first term to make it 5 over 2, but not necessarily enough value for us to start to break this up piece by piece and just reduce each section by its own amount. So that's just 2 examples where we're adding and subtracting with unlike denominators. And we'll leave it at that. So thank you again for watching, and as always, please ask questions if you have them.